Let's continue the rate equation. In our last lecture, as you remember, we started the rate equation, and the last thing what we studied there was the population difference, the rate of change of the population difference, the rate of change of the population difference. What was the population difference? Delta n is equal to n1 or n2. You remember that is n1 minus n2. Okay, and we also studied that the population inversion is started when delta n is less than 0, that this level highly populated should be. Okay, uske baad we made some substitution, if you see, and we get this one. Further we apply the condition that the probability of the absorption and the probability of the stimulated emission, we can take it equal, okay, at the same intensity of the incident photon. Okay, so now if we move further, what we get, if you remember the last lecture is also mentioned that the total population of the system remain constant. कि जो टोटल पॉपुलेशन है आपकी सिस्टम की रिमेन कांस्टेंट, ऊपर नीचे जाते रहते हैं, लेकिन जो टोटल जो पॉपुलेशन है वो सेम रहती है. ओके, सो इफ टोटल पॉपुलेशन we say n0 or n0 whatever, so is equal to this one, then if we substitute this here we get this value. Okay, so delta n, the difference if you remember, and you know how to substitute the things here, put the value of n1. Okay, so here what we get here, this one. So this is one of the substitution. Okay, and if you substitute here, yeah, if you substitute you can also, I mean, we know that we know that delta n is equal to n1 minus n2. Okay, okay, so n1 we take it from here. Okay, so what we get, delta n1, okay, is equal to n0 minus n2. We can substitute this one here. ओके, तो इसको जब हम सब्स्टिट्यूट करेंगे तो वो क्या आएगा, डेल्टा n इज इक्वल टू व्हाट, n0, ठीक होगी बात, ये n1 minus n2 minus n2. Okay, so that would be ultimately this one. So multiplication factor 2, ठीक है, 2 factor आ गया इसमें. So decrease of one atom from n2 result in an increase of one atom in n1. ठीक है, n2 n1 यहाँ से नीचे आ गया, यहाँ कम हो गया, यहाँ ज़्यादा हो गया, ठीक है, but the total remains same. So now we have this equation, substitute the values here. Okay, then you can expand these steps. So the rate at which the population difference occurs, the rate at which the population difference occurs is directly proportional to W21, probability of stimulation, okay, stimulated emission, which in turn is proportional to the incident light intensity. Here, यहाँ पे आप देखेंगे, the rate at which the population difference occurs is directly proportional to W21, okay, and which in turn is proportional to the incident light intensity. Okay, so ये आपने इस इक्वेशन से somehow conclude किया है. This is just a mathematical steps, there is nothing to not deep conceptual levels things are here. So higher incident stream of photon leads to a higher rate of stimulated emission. Higher incident stream of photons leads to higher rate of stimulated emission. Incident stream of photons क्या है? That is your pump. Externally you are applying there. Okay, that leads to higher rate of stimulated emission. Okay. Now if we move further, at steady state, the rate of change of population difference is 0. At steady state. ठीक है, steady state condition, the rate of change of population difference is different. Okay, up down ऊपर नीचे हो रहे हैं, लेकिन difference जो उसका steady state है वो 0 है. Okay, if we consider this thing, then the equation will be like this. This is okay. Further simplify, what you get, this thing, the change, okay, the difference is equal to n naught 1 plus 2 omega to 1, okay, stimulated emission, and tau to 1 is spontaneous emission. So what it's saying here, at low pump power, omega to 1 tends to 0. Okay, at low pump power, omega to 1 tends to 0. So the population difference is simply that of number of atoms in the system. Okay, so at low pump power, तो at low pump powers omega to 1 tends to 0. जब pump power low होगी तो stimulated emission मुमकिन नहीं है. ठीक है, so क्या कह रहे हैं, the population difference is simply that of the number of atom in the system total. So okay, the population difference जो है वो क्या होगा, the number of atom in the is simply the number of atom, total number of atom in the system. ठीक है, पंप पावर क्या है, इंसिडेंट फोटोन जो है आपके. ठीक है, अगर वो लो हैं तो ये जो है वो 0 हो जाएगी. ठीक है, तो अगर ये 0 हो गई तो if this one is 0, so what you get, the n over n naught over 1. ठीक है, so what is this actually? So the population difference is simply that of the number of atom in the system. Difference is equal to total number of atom in the system. Okay. हाँ जी, इसमें क्या कहा जा रहा है कि at high pump power omega to 1 or W to 1 become large, obvious, अगर पंप पावर बहुत ज़्यादा होगी. ठीक है, in this case delta n tends to 0, excuse me. So उसी इक्वेशन को आप कंसीडर करेंगे, is equal to not 1 plus 2 to 1 tau to 1. okay, so अगर ये इसकी वैल्यू लार्ज हो गई, ठीक है, ये वैल्यू लार्ज हो गई, ये सारी लार्ज हो गई, then delta n tends to 0. Okay, so what will happen? So strong pumping will bring 1/2 of the atomic population to the upper level. तो ये क्या शो कर रही है? What it's showing that if the pump power is stronger, तो क्या होगा, half of the atomic population to the upper level. So inversion develop करेंगे इस तरह. क्रिएट करेंगे, अचीव कर लेंगे, ठीक है। एंड 1/2 टू द लो लेवल, ओके। सो आधे ऊपर चले जाएंगे, आधे नीचे आ जाएंगे, देयर इज नो पॉपुलेशन डिफरेंस, ठीक होगी बात। सो when there is no population difference, there is no population inversion. So if there is no population inversion, there is no lasing. So that is why two-level laser system doesn't exist. Okay, or further point is mentioned here. So inversion cannot be achieved in two-level system. So N2 would be thermally populated according to the Boltzmann statistics what we have studied before. Okay, so जब ये population inversion यहाँ पे develop नहीं होगी, so that it means there is no two-level laser system. ठीक है, अब इस ग्राफ में क्या शो किया गया है, द पंप पावर, ओके, और N2 N1 level, N2 level. So it's going, if you increase the pump power, it's also increasing, okay, they are together, there is no population inversion, okay, so there is no population inversion. So this is how what we studied the rate equation for two-level system, which is not existing, but we start from a simple. Okay, so we'll continue the rate equation for 3 and 4 level lasers in upcoming lectures.